All right, so we are going to go through the review for the current unit. So just a couple typos that will be fixed by the time you actually see it, but on the video they're not fixed. This should be Unit 6, and this should say Ionic. So there might be more, but those are the ones that I see right now. All right, so be able to use your charge chart to help you find the names and formulas for ionic and covalent compounds. Okay, so charge chart is this right here. Okay, you guys should be pretty familiar with this by now. It has all your polyatomic ions. It has the prefixes for the covalent compounds, and it has the variable charged ions for ionic compounds. Okay, anytime you have a variable charge ion in a compound, you must use Roman numerals. Okay, if you do not have a variable charge ion uh, in your compound, then you must not use Roman numerals. And we'll go over that as we go through the review. Okay, what kinds of atoms will gain electrons? What kinds of atoms will lose electrons? All right, so if we have an atom that gains an electron, it becomes a negative ion. Okay, now generally, when we have a negative ion, that is a non-metal. Okay. And then the opposite is true for the what kinds of atoms will lose electrons. Generally, generally metals lose electrons, which make them positive ions. And however many ions they lose is what determines what the charge is. And same with however many electrons it gains. Okay. If you gain 2 electrons, you're -2. If you lose 3 electrons, you're +3, and so on. All right, rules for naming covalent molecules. So first we identify the two different elements. Okay, so if it's carbon and sulfur, okay, that's how we identify it. We use the prefix for however many atoms there are in there. Okay, so if the subscript is a 2, we use a di. If the subscript is a 3, we use a tri, and so on. Okay, if there is no subscript, that means there's one. Excuse me, and that means we have to use mono, unless it's the first compound in the. I'm sorry, the first element in the compound. So, for example, if we have CO, okay, we are going to use the mono for oxygen. Okay, so it's going to be monoxide. Okay, but for the carbon, since it's the first element in the compound, we are not going to use mono. We are just going to name it normally. Okay, and then the other thing that you have to make sure you remember, I already did, but you have to replace the second part of the compound's ending with IDE. So notice it is oxide instead of oxygen. Okay. The prefixes for numbers 1 through 10, they are listed on your charge chart. They are right here. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay. All right, next. Are there any ions that have multiple charges? Yes, there are. Which ones? They are located on your charge chart in the variable charge ion chart right here. All of these have multiple possible charges. Okay. How can you tell the charge? Well, you can tell the charge by looking at the Roman numeral. Okay. So, for example, if we have iron Roman numeral 3 oxide, that means this particular iron has a charge of +3 because we have a 3 Roman numeral. Okay. All right. What rules exist for determining the name of an ionic compound? There are a lot for this. I'm not going to write all these down, but we are going to talk about all of them. So first, we just name the cation. Okay, the first part's relatively easy. If it's an element, we just name the elements. Okay, so sodium, lithium, strontium, you just name that positive ion. The positive one will always be listed first. Okay, if it is a polyatomic ion, so ammonium, that's really the only positive polyatomic ion you guys have to worry about. You just name that. Okay, so the first part, pretty easy. You just say or write down the name. Okay. If it is a variable charged metal, okay, so if it is in the charge chart right here, okay, then you do need to figure out what the Roman numeral is, okay, and you do that based on the charge of the negative ion, which we will do a few examples of down below. Then after you're done with the cation, you name the anion. If it's just a single element, you replace the ending with IDE. If it is a polyatomic element, a polyatomic ion, you do not replace the N. Whatever the name is on the charge chart, okay, so any of these names, you do not replace it. You just write it as is. So it is going to be, so NO3 minus 1 is going to be nitrate. You will not replace the ATE with IDE. That is a different thing, okay? When is it appropriate to use Roman numerals? We already talked about that. That's when you have a variable charge variable charge metal in your compound. They stand for that charge of whatever that ion is. What is the overall charge of an ionic compound? That is always going to be 0 or neutral. Ionic compounds always have to balance out. They always have to have a neutral charge. So if we have a -2 charge on one side of the compound, we have to have a +2 charge on the other side of the compound to cancel that out. Okay. So rules for determining the formula. So first we just find the symbols. Okay, so sodium is Na, chloride is Cl. Okay, then we find the charges. Sodium is +1, chlorine is -1. Okay, then we have to balance those charges out. Now, sodium and chloride, they're already balanced out, but if you have a +1 and a -2, then we have to add an extra +1. Okay, again, we are going to be practicing that down below, so I'm going to wait to do that until we're ready for that. And then that is all for that. Okay, so now we're going to actually do some of these practice. Okay, so we have PBS. So we look up the elements on the periodic table. PB is right here. Okay, I forgot what the other one was. S. S is right here. That's sulfur and that's lead. Okay, now first thing we have to do is determine if this is a ionic compound or a covalent compound. Okay, since lead, I lost it. There it is. Since lead is a metal, that means this is an ionic compound. Okay, if the first element was a non-metal, that would mean this is a covalent compound. But this first element is a metal, so that's an ionic compound. Okay. Next, we have to check the charge chart to see if our metal is in the variable charged metals, which, boom, it is. So what that means is we do need a Roman numeral. Okay. So we have to find what the charge of sulfur is to figure out what the charge of lead is. So sulfur is -2. So that means lead has to have a -2 to cancel it out. So since lead has a -2, it's going to be lead Roman numeral 2 sulfide. And we do replace the ending of it with IDE. Okay. Next, Xe and F. So we identify the two parts. Here's Xe, here's F. Okay. Now, Xe, the first element in the periodic in the compound, is a non-metal. So that means this is going to be a covalent compound, which also means we have to use our prefixes. Okay. So xenon, there is one of, but since it's the first element in the compound, we are not going to put mono. So we're just going to write xenon. F is fluorine, and we replace the N with fluoride or with IDE, so it's fluoride. And then we look for the prefix for 6. The prefix for 6 is hexa. So this is going to be xenon hexafluoride. There we go. All right, so next is BaNO3 2. So Ba and NO3. Now, there are 3 capital letters in this. That means there is a polyatomic ion in here somewhere. Now, this one's really easy to identify because the polyatomic ion is in parentheses. So we don't have to worry about, oh, is it this or that or whatever. It's in parentheses, so that means it is the polyatomic ion. First off, we're going to identify the Ba. Ba is right here. That's barium. It is a metal, which also means it's an ionic compound, but having a polyatomic ion in it also means it's an ionic compound, so we didn't necessarily have to do that. But it's definitely an ionic compound. Next, we are going to look up our polyatomic ion on the charge chart, NO3 I'm sorry, NO3. The 2 means there's 2 of them. So here's NO3. Okay, it is called nitrate. So we are just going to write barium. Oh, I'm sorry, I forgot to check and see if barium was on the variable charge chart. So we're going to look at our variable charge chart. Barium is not on the variable charge chart. So that means we do not need Roman numerals. So we're just going to write it, barium nitrate. All right, next is OBr3. So we're going to find O and Br. There's O, oxygen. Br is right here, bromine. Oxygen is a non-metal, so that means this is a covalent compound, which means we need our prefixes. So O, there's one of them, and it's the first one. So we're just going to skip the mono. Oxygen, and then Br is bromine, which we're going to replace with bromide, and there are 3 of them, so we're going to do tri bromide. Okay, so next we have NaNO2. Now, again, this time we have 3 capital letters, so we have to identify the polyatomic ion in here. The polyatomic ion in this case is NO2. So we're going to identify the 2 parts. We have Na, which is right here, sodium, and NO2, which is the polyatomic ion. So that is right here. So that's nitrate. Okay. Na is not on the variable charged ions. Okay. Oh, and also Na is a metal. So that means it is an ionic compound. Na is not on the variable charged metals. So that means no Roman numerals. So all we got to do is just name both of these parts. So sodium nitrite. All right, next is PbO. So we already identified Pb earlier as lead, and we identified it as having a multiple charge, so that is going to need Roman numerals. And since it is a metal, that means this is an ionic compound. O, we have already identified as oxygen. So now we just need to identify its charge, which is -2. So that means the lead is going to have a +2. So that means this is going to be lead, Roman numeral 2, oxide. All right, P3O8. So we have P and O. There's P. There's O. So we have phosphorus and oxygen. Phosphorus is a non-metal, which means this is covalent, which means we have to use the prefixes. So 3 is tri. 3 is tri. 8 is octo. So tri phosphorus octoxide. Okay, so notice we did drop the O from the octo because the element starts with a vowel. Generally, you want to do that just when it sounds better to do that. And it's going to usually be when the element starts with a vowel. Okay. All right. Next one, CaCr2O. This again has 3 capital letters, which means we have a polyatomic ion. In this case, the polyatomic ion is Cr2O7. Okay. So the other part is calcium, or I'm sorry, Ca. And so that is calcium. That is a metal, which means this is an ionic compound. Cr2O7 is this right here. So it's dichromate. That is the polyatomic ion's name. Ca is not in the variable charge ions, so we do not need Roman numerals. So we just name it calcium dichromate. And that's it. Next is N4O. So we have N and O. There's N, there's O. Both of these are nonmetals, which means this is a covalent compound, which means we need our prefixes. So 4 N's, 1 O. Oh, wrong thing. There we go. 4 is tetra, 1 is mono. So this is going to be tetra nitrogen monoxide. Again, we dropped the O from the mono because the element starts with a vowel and it sounds better. Monoxide sounds better than monoxide. All right, last one. We have MnO2. Sorry, MnO2. So Mn is right there. O is right there. Mn is a metal, which means this is an ionic compound. We look at our charge chart. Mn is in the variable charge chart, so we do need Roman numerals here. Oxygen has a charge of -2. So there are 2 oxygens, which means we have a total negative charge of -4. So that means Mn has to have a total positive charge of +4. So this is going to be, oh, and I forgot to show you guys what Mn is actually called. Mn is manganese. Okay. So that's going to be that's supposed to be a G. Manganese 4, which is IV oxide. There we go. All right, and I actually want to do one extra one because this didn't come up. So let's say we have Cu2S. Okay, so same situation. We're going to identify the 2 parts. Cu is right here. S is right here. Cu is a metal, so that's going to be a ionic compound. We're going to check our charge chart. Cu is on the variable charge chart. So we do need Roman numerals. S has a charge of -2. So that means we have to have a +2 to balance it out. Now, since there are 2 coppers, that means our total positive charge has to be +2, but since there are 2 coppers, that means each individual ion of copper has a +1, which means our Roman numeral is going to be 1 because the Roman numeral tells us what the charge of each individual ion is. So like that. Okay. Okay. So next we're going to do our formulas. Okay. So copper 2 sulfate. We identify the two parts. So again, you're going to check the periodic table for that. I'm not going to go to the periodic table for every one of these since we did it so many times up here, but that's how you identify the two parts. So copper is Cu, and it has a +2 charge because that's what the Roman numeral says. Sulfate, okay, since it ends in 8, that means it is a polyatomic ion. So you look it up on the charge chart. Sulfate is SO4 -2. Now, since they both are -2, we don't have to add anything extra. So that's just going to be CuSO4. They are balanced out and good to go. Next is phosphorus pentachloride. Now, since we do have a prefix on the chloride, that means this is a covalent compound. So all we got to do is, since there is no prefix on phosphorus, okay. Oh, and we got to identify it. So phosphorus is P, chloride is Cl. So since there's no prefix on phosphorus, that means there's just one of them. There is a pentachloride, so that means there's 5 chlorides. So that's just Cl5. Okay. Next, lead 2 nitrate. So the 2 means lead is a +2. So we're going to write that down. Pb +2. Nitrate is a polyatomic ion. So you look that up on the charge chart. It's NO3 -1. Now, this time we do not have an equal charge. So we have to add an extra NO3 -1. Now we have +2 and -1, 2. So we're good. So to write this out, we need just 1 Pb and 2 NO3s, but here's the problem. We can't just write a 2 there, right? Because that makes it look like there's 32 oxygens, which obviously is wrong. We don't want 32 oxygens. We want 2 NO3s. So we just put that in parentheses, and now that 2 applies to everything inside the parentheses. Okay? All right, so next up is potassium nitrite. So potassium is K. It has a +1 charge. Nitrite, since it ends in ITE, that means it is a polyatomic ion. The polyatomic ion is NO2 -1, and you can find that on the charge chart. So those ones are balanced. We do not have to add anything else. So that's just going to be KNO2. And we're gonna keep going. Well, yeah, I guess I should say that. So K is a +1 because it is in the first column. All the elements in the first column have a +1 charge. All the elements in the second column have a +2 charge. All the elements in the third column have a +3 charge. Generally, elements in the fourth column don't participate in ionic compounds, or they are multiple charged ions, so they'll have a Roman numeral. So if it's in the fourth column, you don't have to worry about looking at the periodic table to find its charge. Fifth column is -3, sixth column is -2, seventh column is -1. Okay, cool. All right, so next we have sodium sulfite. So sodium is Na. It's in the first column, so it's +1. Sulfite is a polyatomic ion. So you look it up in the charge chart. It is SO3 -2. So right now we have an uneven charge. We have a +1 and -2. So we have to add an extra +1. So now we have 2 sodium. So that's just going to be NaSO3. And there we go. Okay. Next, dinitrogen decafluoride. Okay, so this does have prefixes, which means it's covalent. So all we got to do is write down our symbols. Nitrogen is N, and there are 2 of them because it's di. Decafluoride, that's F, and there are 10 of them because that's what deca is. And that's it. Sulfur difluoride. Okay, so here is a prefix here, which again means covalent. There is no prefix for sulfur, which means there's just one of them. Again, fluoride is F, and there are two of them. So there we go. Chlorine trifluoride. So chlorine, I'm sorry, again, we have prefix, so that means covalent. Chlorine, no prefix, which means there's one of them. Trifluoride means F3. Silicon heptoxide, again, prefix, so that's covalent. Silicon is Si, and there's one of them because it doesn't have a prefix. Heptoxide is O, and that is a 7. I'm 98% sure hept is 7, but let me just double check. Yep, there we go, 7. And last one, tin 4 sulfide. Now, this is a Roman numeral, which means we do have a ionic compound this time. So tin is Sn, and it has a charge of +4. And then a sulfide, which is sulfur, has a charge of -2. So we have an unbalanced charge here, which means we need to balance it. So we have to add another S, -2. Now we have a balanced charge. So it is Sn, S2. And there we go. That is it for that.